Zombie Apocalypse.
Okay, so today's topic is the principle of virtual work method. So, tatry natin tingnan ngayon kung paano natin sisimulan yung usual na pag-analyze ng mga deflections and or deformations, no? So, this will be actually the primer topic for us to analyze beams, frames, and trusses, no, using this concept. So, let's be ready to be neurorized. Okay, what you can see here is just only a structural modeling or an object modeling when it is actually subjected to a value. Let's say this is the object or the material or simply say the structure with the supports, no? Nakikita niyo po yung parang mga ball rollers. So it will act as just like any support, no? And then suddenly, when you try to apply P prime, unit value 1, okay, at point A, so kaya assuming tension, most likely, the element of the structure will tend to increase the cross-sectional area on that particular direction. So meaning, every load that you will apply, of course, as you increase 1 into a value of 2, 3, 4, 5, or whatsoever, it will also possibly increase, no, more values for the change of length or the change of cross-sectional area as depicted here. Now, L represents the possible length, no? The length of that particular element. Okay, so that is when being subjected to a virtual load P prime that's equal to 1. So it is actually any unit. So what if we simultaneously apply any given loads at any given direction? Just like what P sub 1, P sub 2, P sub 3 depicts. Of course, may mga tinatawag kang resultant deformation, delta, na pwedeng kunin yan as as the product of the components. So kaya that's why we can also obtain a differential length here, no, that we do not know right now. So therefore, by this, so we can say the result of the possible deformation, no, by applying a load value, let's say a unit value, is dependent on the number of the values, okay? The number of the applied real loads dun sa ating given condition. And then, of course, dependent na, no? Nagvavariate na, I mean, yung ating deformation, no? In the form of possibly deflection. That's why energy in is equal to energy out. Work from the load, of course, external load will cause the work on the internal load. So, upon entrance, okay, and upon absorption. So, that's what the principle of visual work method will go along. Okay? Suppose that we have the energy in, okay, and this will serve as the energy out, okay, out. So therefore, as you apply the 1 unit value, will correspond to a specific deformation that's also equivalent to the possible work done, no, by that particular element. So again, to depict the idea, P prime represents the 1 or the external visual unit load acting in the direction of the delta. So kailangan they should come in pair. U as the internal virtual load acting on the element in the direction of the strip of the length, ano. So ito pa rin yung differential value. So then delta as the extraction of the external displacement caused by the real loads, and the differential length dl, internal deformation of the element caused by the real loads. So makakuha natin yung totoong deformation niya if we take all the summation. So again, sabi dito, by choosing P prime is equal to 1, it can be seen that the solution delta follows directly, since 1 delta is equal to sigma udl. So meaning that if you divide it by 1, then it can be simply say, mentioned, no, na ito na po yung primary equation natin. But the question would be, how to treat beams, frames, and truss. So tingnan natin kung paano, by this simple idea. Also, pag rotation, ganun din naman. Kasi ang material mo, when being subjected to any direction of forces, so of course, it will suddenly experience rotation. Kasi ito yung load natin, W, ito yung beam deflection. So, of course, may reaction ka dyan, okay? So, may mga portions ka na makikitaan ng mga slope, okay? So, ganun, palitan mo yung delta ng theta naman, and u as u theta. So, this will be the same definition, but this time, imbis na 1 unit load, apply mo dito is 1 external virtual unit couple or 1 unit moment. Okay, how to treat trusses. So what you're going to do, that delta on the specific direction is equal to small n b times big N L over AE. So notice that there's a sigma. So let's say if you have delta in question in the real sense and you need a two direction, then it can be said that the delta is equal to delta x, okay, squared plus delta y squared, okay. So, ito is dependent kung is this x or y. Okay? So, therefore, this will also depend as x or y. So, para makuha yung true deformation, then take the Pythagorean value just in case, no? So, again, what is the nomenclatures used? So, one, of course, the unit value. And represents small n represent internal visual normal force in a truss member caused by the reserved visual unit load. Ang gagawin nyo po dito is kung anong tinatanong na joint displacement, maglalagay kayo ng 1 unit load. Then you try to analyze. Say, if you have a truss, kunwari, sample lang po ito. Okay, yan. Okay? And then, you want to ask what should be the deformation or displacement of this joint. So, gagawa ka ng simulation. If you think na ito'y papuntang kanan, then apply 1 unit load if horizontal ang tanong. And if you think na ito ay tataas, then apply a 1 unit load that goes up. Okay? If there's a to be negative on the final answer, then it is just only the reverse direction, no? Pero pag positive yung naging answer natin na delta, therefore, tama assumption yun ng direction. Okay? Ang sinasabi lang ng small n na to is you are to apply a unit load based on the joint that is being asked. Depende kung horizontal ba or vertical or yung resultant. Okay? Ito yung resultant, yung delta squared. Okay? And then, para makuha yung small n, you apply 1 unit load and then proceed with the method of joints or FBD, no? Sa truss na napag-aralan na during your statics. Okay? And then the delta is actually the depiction of the external joint displacement caused by the real loads of the truss. Yan yung tinatanong. Okay? Na pwedeng delta x, okay? Pwedeng delta y and also a delta. So, definitely, delta muna. Pag ang x, then subscript of x sa lahat. And y, subscript of y. Ang bigyan naman, ito yung due to the actual loads, no? Kung ano yung load na nakinarga ng truss, no? Huwag mo siyang aalisin, huwag mo siyang gagalawin. Then, calculate as is. Then, you will find this value. Then, the length of the member, okay, given na yan. A and E, area and cross-sectional area as A. And modulus E, no? Yan, binibigay naman ng given yan. If not, then we can assume that it is similar, same values of E, A, and E. Or yung tinatawag nating rigidity condition niya is same, no, throughout. Okay? So, yan po yung depiction na sinasabi ko kanina. Ganito naman po ang ginagawa pag beams and frames. Okay? Ang equation po niya, actually, this is a sigma equation. Okay? Sigma equation from 0 to L, no? MMEI dx. So, you have to get the summary of all segments. So, let's say, kung may mga segment cuts ka dito for every change of the load, you have to pass a cutting plane. So, maraming way yan. So, pwede ito yung distribution ng X mo. Okay? Galing sa iisang point. Okay? Or pwedeng sa kanya-kanya segment ka nag-start. Let's say, dito, o kaya dito, o yan, it's up to you. Kasi dependent lang naman yung limiting distance natin kung 0 to L yung gusto nyo gamitin or whatever it is. Actually, I can call it x sub 1 up to x sub 2 kasi definitely, hindi naman sigurado kung 0 to L lagi yan. It can vary, no? So, it's regardless. So, let's say, nangyari lang sa isang common point na nagsimula sa origin on the leftmost, then it is 0 to L. So, what is small m and big M? So, yung small m, it is actually the member forces, no, assign with the influence of the one unit load. As we call it, the external visual unit load. So, parang isosolve mo yung beam natin na meron kang kinakargang 1 unit load on the specific point na hinahanapan, then solve as is, ano? Then the big M is actually the true internal moment in the beam based on load. So, ganun din yung setup. Kailangan yung pag-solve ng big M at saka small m is iisa lang yung kanilang limits or coordinates. Otherwise, you cannot combine them if you are setting different x distance from the computation small m and then different set distance for big M. So, they won't comply. And delta as is, ano, deformation, ganun din po, delta x and delta y. So, pagka delta y ang hinahanap, then apply 1 unit load for y. And paghirapin yung horizontal, and then for actual reasoning, apply 1 unit load as a value, then to the x direction. Okay? Ganun din assumption, kung sa tingin mo, yung beam natin is bababa, or frame mo is may parting bababa, and then apply 1 unit load, pababa. Pagka pakanan, sa tingin mo, hatake siya pakanan, so will deform to the right, then it should be going to the right, no? Pag nag-negative, ibig sabihin lang po nun is, it is actually a wrong assumption of the direction, but the value is correct din. Same lang din. And EI is given, or the flexural rigidity, or where is the modulus of the city of the particular axis in question, the stronger or the weaker axis, and I as the same condition but the moment of inertia. Likewise, kung ang tinatanong naman is rotation, let's say may point ka dito, hinahanapan mo ng rotation, specifically, so kung kanina nag-apply ka ng 1 unit load, dito mag-apply ka ng 1 unit moment. Okay? So, nagkapalit lang po yung small m, naging m theta, whereas m theta is the member forces when you apply the 1 unit moment. Whereas the big M is the same, na kung ano yung load na in-apply, then calculate as the member forces. Nagpalit lang. So, dito theta naman yung nahanap. Okay, so that's it, ano? Yan yung concept ni visual work method. So after this video lecture, we will try to apply that in a series of problems so that we would understand how to apply that in a beam, in a frame, and in a truss. Okay, so thanks for viewing. Please subscribe to my YT channel. Don't forget to hit the like and share button below. So again, our very tradition. Thanks for viewing, and salamat. And then you have been neurorized. See you in our next video lecture.